If you've never used Peaksel before, this video is a good starting point. We'll cover the basics like uploading raw data, grouping individual injections into batches, registering analytes and extracting chromatograms, editing those chromatograms and creating beautiful reports with charts and tables. Let's begin. We don't have any injections at the moment, so let's upload some. We can upload the data using the buttons on the screen or simply by dropping the file on the page. In front of me, I have a list of Agilent raw folders. First, I need to zip them. After that, I just drop the archive onto the page. Now that it's uploaded and processed, I can open each injection separately. I can also group them into a batch right away, but for now, I'll just look at them as a list. If I have just a few rows, I could select them one by one and group them into a batch. But if I have many, it's more convenient to search for them by their prefix, and then create a batch out of the found ones. Let me first skip a couple of steps and show you the end result. This is a batch page where I processed and grouped almost 200 injections. Peaksel is extremely fast. It can handle thousands of injections per batch, though it's advisable to keep them under 3,000. Here you can see the analytes. While they have the same logical name within the batch, injections can associate different structures with these aliases. We can highlight samples where each of them was identified, build data tables, create charts, export data, and so on. These visualizations are linked. If you highlight something in one table or a chart, the relative data is highlighted everywhere. We'll return to this page later. For now, let me show you what you can do with the chromatograms. I'll jump to this well, for example. We can see two analytes here, as well as their peaks. We can also see a total ion chromatogram, two extracted ion chromatograms overlaid on top of each other, a total wavelength chromatogram, and an extracted wavelength. Now, I see a problem. The detectors are misaligned. Probably this happens across the whole batch. Let me check the neighbor. Yep, here the signals are misaligned too. To fix it, let me drag one of them by the x-axis to align it with the other detector. And that's it. That's how easy it is. Of course, I don't want to do this for every injection, so let me apply the same alignment to all injections using this pop-up. See how fast it was? We just reprocessed 200 injections in the blink of an eye. Let's return to the previous well and check. And yes, I didn't lie. They got aligned too. Notice that some peaks were automatically selected on the UV chromatograms. Peaksel uses extracted ion chromatograms to identify the analytes, and after that, it cascades the peaks to others. But for some reason, this one wasn't selected. Why? Probably because the current integration method doesn't recognize it as a peak at all. So let's fix it. I'm going to the integration method. There are three types of settings to pay attention to. Smoothing is needed so that we don't mistake noise for signal. Let's play with it on a noisy chromatogram to see the effect. The lower the level of smoothing, the noisier it gets, which results in more peaks. Good enough. Next one is detection. Here we can control how sharp a bump in a signal should be in order to be considered a peak. The current algorithm uses a second derivative to find the peak apices. If the threshold intersects the derivative, then the peak is detected. Let's lower the threshold to make it happen. As you can see now, the bump is highlighted green, and so it's recognized as a peak. Finally, the filter tab. It has additional criteria that the peak must meet in order to be selected. In this case, it's the minimum area threshold. We have a separate tutorial that dives into the integration algorithm and explains how it all works in detail. See the links in the description to this video. Okay, now let's apply the new settings. Now the peak is selected. Most likely other injections need the same changes, so let's return back to the integration method. Instead of updating just this injection, we'll apply this method to the whole batch. Again, just a few moments, and 200 injections have been reprocessed. Besides the automatic integration, we can create and modify peaks and the baseline manually. Notice that a lot of the actions have shortcuts. I'll close the menu and try that. Cool. Now we can move the peaks around, change their widths, delete them with the right click of the mouse. Now I'll switch to baseline editing. That's how easy it is. Manual editing takes priority during the integration. Even if you change the automatic integration method, it won't overwrite your manual changes. That was chromatograms. It's time to explore spectra. We'll start with mass spec. If we edit an analyte, we can change its mass spec settings. Here we see a list of charged and neutral fragments that are either added or removed from the analyte, and the respective list of ions that are generated with those fragments in mind. Maybe you want to measure both hydrogen and sodium ionized species? Let's do that. And for the fun of it, let's look at multiple charges. As you can see, the expected ion distribution changed. We can further fine-tune it. We can select ions that will be part of the peak area, so-called quantifiers. If we uncheck one of these, the peak area will get smaller. We can also choose the ions that are used in isotopic pattern matching, aka qualifiers, and qualifiers ensure it's really our analyte and not something else, by checking if the measured intensities resemble the expected distribution of isotopes. We can add or subtract not only charged ions to the analyte, but also neutral fragments. This is useful in case the molecule reacts before it gets detected. A common use case for this is deprotection. Now we track even more ions. Once applied, the EIC traces are reintegrated and the peaks are redetected. Double-click on the peak label to see its spectrum. The highlighted regions are those where we expect the analyte ions. We can inspect the actual intensities here. The qualifier ions also have expected ratios, with the thresholds as horizontal bars. If the measured proportions are different, then it must be some other molecule with a similar mass. Such a peak wouldn't be selected if that were the case. It's also possible to see a spectrum of any point on a chromatogram. If you're interested in some particular mass, you can click on it to see when it was eluted. We call these transient traces, as they will disappear after the page is refreshed. You could also permanently extract a chromatogram by double-clicking on the spectrum. That was mass spec. What about PDA? It's a similar story. You can look at transient traces by clicking on the spectrum. And when ready to extract, you either do this from the menu or simply by double-clicking on the wavelength of interest. We just extracted a new chromatogram with a simple double-click. Almost anything you do in a single injection, you can then apply to others. Here, I'm extracting yet another wavelength and applying it to all the wells. Waiting a second, and it's finished. Let's look at another well. And here's the wavelength. By the way, navigation between wells is like a game in Peaksel. Look at the shortcuts. WASD are commonly used to navigate across the terrain in computer games. Check it out. This frees your right hand to stay on the mouse, which in turn allows you to quickly navigate and modify chromatograms at the same time. Anyway, it's been fun, but let's return to the batch level summary. I skipped this before, but how did we actually get these analytes here? Peaksel allows uploading structures in two ways. If the same structure is associated with all the wells, we can just upload that structure and select the wells to which it should be added. After that, the respective chromatograms were extracted and the peaks were detected automatically. Notice that I used smiles, but I could also use molecular weight, molecular formula, mole or SDF files, and even inchi. Now, what if different wells needed different structures? Then we should either upload a CSV, Excel, or an SD file. No matter what we choose, the files should contain the analyte chemical information, the compound alias, and the corresponding injection name. I could just show you the file, but what would be the fun in that? Instead, let's create it right in Peaksel. This is a good segue into building reports and exporting data. First, We use the Visualize menu that allows us to create tables. The table can contain injections as rows, in which case the peak information would be in columns. Or we can pivot it and have peaks as rows. I'm selecting peaks as rows. Now we can choose which columns to add to the table. As I mentioned, we're interested in chemical information, so let's choose molecular formula. Then we need an alias. And the injection name is already checked. We'll need the chromatogram name too. And also we need to know if it's the largest peak. In a sec, I'll explain why. The order of columns is important. First goes molecular formula, then the analyte name, and then the injection name. The reason we need chromatogram name is because right now we have duplicate rows. If prod 1 is selected on 5 chromatograms within a single injection, we'll end up with 5 rows. We need just one, so let's use filtering and leave only EIC peaks. I'll copy the column name that I'll be filtering on. Go to Filter and enter an expression. Column. Chromatogram name must contain a word EIC. Additionally, it's rare but possible that the same mass is identified in more than one peak. This also creates duplicates. So let's add another condition. In such situations, only one of the peaks is marked as the largest. The 2 ampersands operation means that both conditions must be true to leave the row, the rest are filtered out. This syntax can be used not just for filtering, but also when adding columns with custom expressions. You can find the documentation here. Let's save this. Now that we got rid of the duplicate rows, we're ready to export this table into a CSV. If we open the file, we notice that it's not really comma separated. Rather, the separator is a semicolon, which is important when you create such files yourself. Files like these can be opened in Excel. By the way, instead of uploading a CSV, often it's easier to just copy the content from Excel and paste it directly into Peaksel form. Before doing that, let me delete all my current analytes. Now, if we open injections, we don't see EIC chromatograms anymore. Now I'll add all those compounds back by uploading my mapping. Couple of seconds and the analytes are uploaded. If we open the injections, we'll see that the chromatograms are extracted and peaks are integrated. And that's it for today. We covered a lot, but it's only a small part of what Peaksel can do. We didn't cover automatic data importing, data sharing, permissions, organization and user management, charts and statistics and visualizations, and many more topics. So get registered for free and start playing right away.